Alrighty, so this video is our math review for trigonometry. Trig, like algebra, is a critical piece of mathematics to know to be able to be successful in physics, to be able to solve problems. You will see why in a future lecture, but just as a preview, it's because almost everything you ever do in physics requires the use of what's called a vector. Vectors allow us to talk about information in a much more efficient way, to give more information, more data, with less steps. So, for instance, one example is speed. Speed is what's called a scalar. It's a number. If I ask you how fast you're going, you'd say 35 miles per hour. That's a speed. However, if you gave me a vector version of speed, that would be called your velocity. And a vector version, the velocity, not only tells me how fast you're going, but also tells me what direction you're going in. So you'd say, I'm going 35 miles per hour on Joe Yenny Boulevard heading north. Well, that gives me much more information with the same number of things. One was speed, gave me how fast. The other is a velocity, and it tells me how fast and in what direction. In order to use vectors, we need to be very proficient in trigonometry. Now, not every aspect of trigonometry is necessary. If you remember, when you took trigonometry, it basically dealt with triangles and how to manipulate triangles, or how to use the information given on one triangle to get more information that's unknown, and so forth. We will concentrate to special cases where the triangles are right triangles. So that is to say, when you're given a triangle, one of the angles is 90 degrees. So there's a right triangle. When we specialize to right triangles, then we're looking at a subset of trigonometry that makes things a lot easier. So what do you need to know to be good with right triangles? Well, the first thing is called the Pythagorean Theorem. And what the Pythagorean Theorem tells you is it relates the lengths of the sides of a triangle. So, let's say I happen to know that this triangle, the bottom side length is 3 meters, and this top side length is 4 meters. And I say, how long is this side over here? Well, first of all, there's a special name for that side of the triangle. This side, R, is the side which is opposite to the 90-degree angle. Because of that, it must be the longest side of my triangle, because this angle, the 90-degree angle, is the biggest angle of the triangle. So that side has a special name. It's called the hypotenuse. So, what does the Pythagorean Theorem say? Well, it says that the sum of the squares of the two sides of the triangle, that is to say this side and this side, must equal the square of the hypotenuse. A lot of times you'll see it written a squared plus b squared equals c squared, where one side is called a, one side is called b, and a hypotenuse is called c. So, for our particular triangle, our example here, if I'm looking for r, I would be told 3 squared plus 4 squared must equal our r squared. Alright, that's not so bad. So let's plug in my numbers. 3 squared is 9, 4 squared is 16, equals r squared. 9 plus 16 is 25, is r squared. Well, I don't want r squared, I just want r, so I have to take the square root of both sides. So I'm told r must be 5. So I now know the length of my hypotenuse is 5. And that's what the Pythagorean theorem can do for us. If you know 2 out of the 3 sides of a right triangle, you can get the third side using the Pythagorean theorem. In this case, the third side happened to be the hypotenuse. However, what if we have an example where it's not? Let's say I have this triangle here. This is 10, this is 6. Let's call this x. All right, well, now I want to find out what's the length of side x. Well, first of all, I can see this is my right triangle, and that means this 10 side is my hypotenuse. So I know Pythagorean theorem would tell me x squared plus 6 squared must equal 10 squared. Remember, the hypotenuse is on one side, and the other 2 smaller lengths is always on the other side. All right, so we have x squared plus 36 is equal to 100. I want to get the x by itself, so I'm going to move the 36 over to the right. That becomes 100 minus 36, which is 64. Again, I don't want squared, so I take the square root of both sides, and that tells me x must be 8. So I know the length of this side must be 8. So that's the Pythagorean theorem. If you know 2 of the sides, you can get the third side quite easily. What else do we need to know for trigonometry? The next big thing is called Sohcahtoa. Now, this is how I learned it when I was growing up, and I think most people learn it this way too. But I have seen a friend of mine in college, he was from Honduras, and apparently they didn't teach Sohcahtoa where he's from. They taught it some other way, and I don't know the other ways. All I know is Sohcahtoa. But this is basically a little mnemonic. Helps you remember relationships about triangles. And so let me draw a little triangle. I'm going to call this angle here, I'll call it theta. Here's my right triangle. Now if this is x, this is y, and this is r, what is Sohcahtoa telling us? Sohcahtoa is a way of remembering how do the side lengths relate to the angles inside the triangle. Well, one relationship we already said was that whatever side is opposite to the right angle, that's the special side called the hypotenuse because it's the longest. Well, there are other relationships too. And what these things say, let's take so for instance, that says that the sine of the angle theta is equal to the side which is opposite to the angle. So the side opposite to the angle is that side over there, y, divided by the hypotenuse, the h, r, in this case. So is sine, opposite, and hypotenuse. So the sine, which is just a function in your calculator that you could plug in, and it'll give you a number. But if I take the sine of that angle theta, whatever that number is, it's the same as if I took the length of side y and I divided it by the hypotenuse r. What about ka? Very similar. The ka part says the cosine of my angle theta is equal to the side which is adjacent. That's what the A means. Adjacent to the angle. Well, here's the angle. The side which is adjacent means next to, of course, is this side here, x, divided by h, the hypotenuse, which is r for us. So that says cosine, adjacent, hypotenuse. And then lastly, toa says the tangent of the angle theta is the side opposite, which for this angle theta, the opposite side is my y, divided by the adjacent, which for that angle is x. So that's what Sohcahtoa tells me. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, do not remember cosine goes with x and sine goes with y. That's not true. Cosine goes with adjacent, sine goes with opposite. For this example, the opposite side happened to be y. But that's not always true. Sometimes the side adjacent will be y. For instance, take this triangle. Let this be my angle phi. Here's my right triangle. Here's my x. Here's my y. Here's my hypotenuse. If I say, okay, what's sine of phi? Well, sine is opposite over hypotenuse. If I put y over r here, I'm wrong. Because the side which is opposite to my phi is that one there, which is my x. Cosine for this one is y. So you have to be very careful. Remember Sohcahtoa, sine is opposite over hypotenuse, and then look at the triangle and see which side is opposite. That's the side which goes away from the angle. And which side is the adjacent side? That's the one that's right next to the angle. And of course the third side is the hypotenuse. But if you remember Sohcahtoa, it's easy to remember these relationships here. Now, why is that important? Well, it could be that you need to know what value is this theta. So let's take an example. Let's say I have this problem here. Let's say this is 3, this is 4, this is phi, this is theta, this is r, and this is my 90-degree angle. The question is, find r, theta, and phi. Okay, well, let's see. How do I do it? First thing I could do is I could find r quite easily using Pythagorean Theorem. 3 squared plus 4 squared is r squared. And I did this before. We already know r is equal to 5. So there's one of my answers. How do I find theta? How do I find this angle over here? Well, there's different ways of doing this. I could use sine. If I wanted to use sine of theta, then I'd have to say, okay, sine, that's so sine is opposite. Opposite to theta is the 4 over hypotenuse, which I just found was 5. Okay, well that's fine, but how do I solve this equation for theta? Well, in order to do that, let me just put a little aside here. When you have something that looks like this, 5x equals 10, and I say, okay, I want you to solve for x, what do? Well, what everybody says is, well, you just divide by 5 to get rid of the 5. Do it on the other side, that becomes 2, so you get x is equal to 2. And that's true, but why did you divide by the 5? We had (5x is equal to 10). I wanted to get rid of the 5 because I wanted x by itself. In order to get rid of the 5, I have to do what's called the inverse operation. That cancels out what I'm doing. Because if you think about it, what this is saying is multiply x by 5. But I don't want to do that. So in order to undo that, I do the inverse thing, which is divide by 5. Because dividing by 5, when you multiply by 5, cancels each other out. The same thing is going to be true over here. Here, I want theta. But I don't have theta, I have the sine of theta. So I'm doing an operation of taking the sine. So if I don't want to do that, I have to do the inverse operation of taking a sine. What is the inverse of taking a sine? It's called inverse sine. So I take this term and I do what's called the inverse sine of it. And that cancels the sine part. Just like over here, dividing by 5 got rid of the multiplying by 5 aspect. On the left, taking the inverse sine got rid of the sine itself. However, in order to do it to one side, you have to do it to the other as well. So on this side, I also have to take the inverse sine. And so what am I left with? I'm left with theta on the left, because the sine's canceled, equals inverse sine of 4 over 5. Now, unfortunately, this you can't just do by hand. This, you're going to use your calculator. And when you use your calculator to solve for this, you should get 53 degrees. Here's a little tip. Make sure, because we're solving for degrees, your calculator is in degree mode. I know a lot of times in mathematics they want you in radian mode. Here you have to use degrees. We're going to use degrees in physics, so use degree mode. So that's how you can find theta, using the sine. We started with sine of theta is opposite over hypotenuse. But then we didn't want sine of theta, so we had to do the inverse sine of both sides. That left us with theta equals the inverse sine of 4 over 5. You plug that into your calculator. That gives you 53. Theta is 53 degrees. I now have my theta. Now, before I move on to phi, note I didn't have to use sine. I could have used cosine. If I used cosine instead, I would have had cosine of theta equals, well, cosine, that's the ka, that's adjacent. So the side adjacent to theta is 3 over 5. And the same kind of a thing. In order to get rid of the cosine, I take the inverse cosine. But I also have to do it on the right side as well. Inverse cosine cancels cosine, so I get theta is inverse cosine of 3 over 5. And again, when you plug this in, you get 53. Finally, the third way you could have done it was using the tangent, TOA part. So tangent theta is opposite, which is 4, over adjacent, which is 3. And likewise, theta is inverse tangent of 4 over 3. So you have 3 options. You could use any of them. Personally, I would have used tangent. And the reason I would have used tangent was because if you notice, when we use sine, we had to use the hypotenuse. And when we use cosine, we had to use the hypotenuse. But the original problem didn't tell us what the hypotenuse was. We found out and calculated a hypotenuse. So imagine if when I did this part, I calculated wrongly, and instead of 5, I got 6 for some reason. Then everywhere in the sine or the cosine calculation, I needed to have my 5, I would have had 6 by accident, because I was wrong in a previous calculation. That means all the answers would have been wrong here and here as well. However, in the tangent part, notice I didn't have to use the hypotenuse, because the tangent only needed the opposite and the adjacent, which were already given in the problem. So for me, because I have experience with this stuff, I know that if I have the ability to only use information given in the problem to solve the problem and not have to use stuff I worked out myself, it's best to do it, to be on the safe side. Because imagine you're at work, you're an engineer, or you're in a lab, and you're having to do a bunch of calculations. Well, imagine you make a little bitty mistake at the beginning of your work, and then you keep using that mistake number over and over for all the rest of your calculations. Everything's going to be wrong. However, if at every opportunity you only use the numbers that were given to you by your boss, then either you're going to be right, or if you're wrong not because you miscalculated, but because the information that was given to you was faulty to begin with. So it's not your fault. Now in this case it didn't matter because I know 5 was correct when I calculated it, and I know I didn't make a mistake, so it's fine. There are going to be times when you don't have the ability to not use something you already calculated. I'm just giving you a little tip for some thought in the future. It's just good practice that if you can solve the problem without having to use your own numbers and only use the numbers that were given to you, there's less likely going to be any errors on your part. But all 3 of these methods work. Sine, cosine, or tangent would have been fine. Now notice there's one more thing we need, which was, if this was 3, this was 4, this was theta, this was phi, this was r, we also wanted to find phi. Now, how can I find phi? I have 2 methods, or actually, I guess 4. I could do phi the same way I did theta. So I could say, okay, sine of phi is opposite, which in this case is 3, over hypotenuse, which is 5. Or I could say cosine of phi is adjacent, which is 4 over 5. Or I could say tangent of phi is opposite 3 over adjacent 4. Okay, that's fine, no problem. The other way you could do it is there's one more relationship about triangles you should know, which is the 3 angles in a triangle add up to 180 degrees. So if I want to use this, what do I know? Well, I know one angle is already 90 because it's a right triangle. I also know if I add the other 2, I'm adding theta and I'm adding phi. This better be equal to 180 degrees total. So bring the 90 over to the other side. That says theta plus phi must be 90 degrees. 180 minus 90. Well, I already know theta from before. I just calculated theta. That's 53. So 53 plus phi is 90. So bring 53 to the other side. Phi then must be 90 minus 53, which is 37. And now I know my phi. So there's a different method. Here, of course, you only want to do this if you know for sure theta was correct. But you could also use these methods here. They both work, and whichever method you want to use is fine with me. It doesn't matter. This is basically all the trigonometry you're going to need, for the most part, to solve these problems. You have to be comfortable knowing when do you use sine, when do you use cosine, which side is the opposite side, which side is the adjacent side, things like this. Adjacent, that just means what's the side which is touching your angle, and opposite means what's the side on the opposite side of your angle. So just be careful you don't get into the habit of thinking cosine goes with x and sine goes with y, especially in the future when we're talking about vectors. That can get very confusing. But if you remember Sohcahtoa, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And you remember Pythagorean Theorem, a squared plus b squared equals c squared, where c squared is the hypotenuse, that's the longest side, or the side which is opposite to your 90, then that's pretty much what you need to know for your trig. So if that makes sense.